Hello everyone, and welcome to Biopedia. A few episodes ago, when I discussed the Wallace Line, I briefly mentioned the Great American Interchange in passing. However, although it is an interesting subject in its own right, there wasn't enough time to go into it, given its tangential relevance to the topic at the time. So, today, let's redress the balance and examine the subject in more detail. The Great American Interchange, also known as the Great American Faunal or Biotic Interchange, GABI for short, refers to the travel of species between the continents of North America and South America after the two continents were connected by means of the isthmus of Panama approximately 3.5 million years ago. To explain why this is ecologically significant, we're going to have to examine the prehistory of South America. It originally made up part of the continent of Gondwana, the southern half of the supercontinent of Pangaea we discussed in episode 49. Gondwana would splinter in the middle of the Cretaceous period, and Antarctica would detach from South America during the late Oligocene period. This meant that South America became effectively isolated, and would remain on its own for tens of millions of years. As such, its organisms would evolve in this isolated state, leading to a unique fauna. As an interesting side note at this point, marsupials actually had their evolutionary start in South America. When today's southern continents were still connected in the form of Gondwana, they travelled through Antarctica and arrived in Australia, hence the presence of marsupials in Australia once it split from all other land masses. Eventually, however, North and South America would connect at Panama. This connection initially started out as a more transitionary one, either in the form of a series of islands between the two continents or as a temporary peninsula. Now, there had most likely been travel between the continents before this point, as I'll return to in a moment. However, the meeting of the two Americas meant that the migrations greatly increased. The exchange of organisms between North America and South America is the GABI, which occurred from 3.1 to 2.7 million years ago. This would be analogous to organisms travelling between Eurasia and India 50 million years ago, or between Africa and Eurasia 30 million years ago when those continents collided. As a brief throwback to episode 49, Alfred Russel Wallace would be the first person to discuss the GABI in 1876. According to the abstract of a 1982 paper in Science, the number of mammal genera that travelled from south to north and vice versa was proportional to the biodiversity on the home continents before they collided, and both continents would experience a rise in biodiversity followed by a drop. That said, North American mammals proliferated more in South America than vice versa. The importance of the physical connection between the two continents has been difficult to pin down in the past, because most studies of the GABI deal with mammalian fauna, and do not concern species, but rather higher taxonomic orders. A good analogy for this would probably be scientists examining only one point of a landscape with an unfocused telescope. Accordingly, one study examined 457 species of passerine birds in 4 families. This is a group of birds which lives in both tropical and temperate regions, and in both North and South America. Within the group sampled, different families of birds had different habitat requirements and capacities to disperse. For example, antbirds and woodcreepers are tropical, whereas blackbirds and tanagers tend to be less specialist. This theoretically impacts the ability to disperse. Blackbirds and tanagers are found in the Caribbean, whereas some antbirds or woodcreepers are hesitant to cross even 100 metres of water. Now, as with most land animals, birds are not as well represented in the fossil record as mammals are. In addition, not a lot of fossils have been uncovered in the tropics. Accordingly, a phylogenetic tree was constructed based on DNA data, and the rate of dispersal between continents before they physically joined was compared with dispersal rates after the formation of the Panama connection. The reason why this is relevant is that species which were able to disperse between the two continents before the formation of a land bridge would not have been impacted by the connection at Panama, and hence the dispersal rates before and after would not differ significantly. By contrast, observing markedly different dispersal rates before and after for a family of birds would indicate that the joining together of North and South America significantly impacted their capacity to disperse. The authors of the study compared two different models of dispersal between North and South America for each family of birds. Specifically, the first model kept the rate of travel between continents the same for each lineage, both before and after the continents collided. In the other, dispersal rate across continents could be different before and after a specific data-derived point in time. Comparing these two would determine if and when a gaby took place. For wood creepers, antbirds and tanagers, the second model best supported the data. Antbirds and wood creepers, both confined to tropical habitats, saw a significant increase in dispersal rate a few 100,000 years after the collision, indicating that the formation of a land corridor played a significant role in their ability to travel between continents. By contrast, the increase in tanager dispersal seems to have come about 6.5 million years ago, indicating their travel between continents began when the land bridge was still forming. That said, a start date of 4 to 3.5 million years ago was almost as supported by the data. The critical date for blackbirds seems to have been 2.9 million years ago after the corridor was already in place, but the probability of this was not statistically significant. Approximate dates for the earliest migration events for 14 families of passerines demonstrated that all three forest-dwelling groups first travelled between continents when the Panama corridor was in place, 3 to 4 million years ago. By contrast, all but one of the 11 generalist families first migrated across continents before its formation. Notably, mammals mostly moved into South America, while travel from North America to South America only predominated in birds before the connection was fully formed, with direction reversing afterwards. However, the paucity of tropical mammal fossils may create a bias. As such, the authors noted that molecular methods could help fill in the gaps in our knowledge. Taken together, the creation of a physical connection at Panama was vital for tropical birds in South America to cross into North America. The traditional narrative is that the impact of the interchange on South American fauna was dramatic, with the gaby resulting in wide-scale extinctions. However, newer research indicates that the introduction of North American fauna into the region was slow and brought negligible biomass south. In fact, the main cause of the extinctions in South America may have been climactic. From 4.7 to 3.1 million years ago, the so-called Pliocene warm period was in effect. This may have been caused by the ocean currents changing, due to the decreased connection between the Atlantic and Pacific Oceans as the two halves of the Americas drew closer together. However, after this point, from 3.0 to 2.7 million years ago, global temperatures dropped. This resulted in a more arid, cooler climate in South America. These conditions encouraged the rise of open habitat, resulting in a savanna arising on the Panama Isthmus connecting the two continents. Some millions of years earlier, plants which undertook a subtly different form of photosynthesis called C4 photosynthesis, which we've covered in a previous episode, arose to become prominent in the previously C3-dominated continent. This took place within a prolonged cooling and dry period, which allowed savannas to establish and expand in the region of Pampas, with a hybrid C3-C4 community established after about 8 million years ago. This change in photosynthetic makeup in the plant community can be seen in the carbon isotope composition of mammal tooth enamel at this point in time. This is because an examination of the isotopic composition allows you to determine the diet and habitat of choice of the organism under study. A 2020 study examined more than 400 samples in 10 orders of mammal in the Pampas region of modern-day Argentina. They examined both carbon and oxygen isotopes in their samples. An examination of oxygen isotope composition, or the relative abundances of oxygen-18 versus oxygen-16, is useful because it reflects the isotope composition of water that the animal drank. Any change in this value in water is mostly a function of yearly temperatures and aridity, meaning it can act as a proxy for these variables. By contrast, the proportion of carbon-13 versus carbon-12 allows us to uncover what organisms of the past were eating, as mentioned above. Different orders of mammals had different responses to the ecological shift. For example, rodents immediately adapted to be able to eat C4 plants, while the order Notoungulata adapted at about the Miocene-Pliocene boundary, with some families becoming flexible while some developed more specialist diets. Before the Gabi in the region of Arroyo Chasico, rodents, Litopterns and Notoungulates all generally ate C3 plants, although the habitat they used differed from each other. However, in Salinas Grandes de Hidalgo after the first wave of the interchange, niches seemed to overlap more, which could be reflective of the more difficult conditions described above. The rise of C4 plants in the Miocene-Pliocene boundary may have helped to decrease competition between herbivores, as shown by the marked differences in delta C values between taxa at this point. As such, the change in vegetation use by native South American fauna was not as a result of North American immigrant species putting pressure on them, although they arrived at about the same time. Added to this, the dietary flexibility of North American species arriving in South America may have helped them to establish and spread throughout the continent. So, that's it for today. As always, thank you for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.